Hello guys, I welcome all of you on my channel Physics Hub. Today is 9th December 2018 Sunday, and here I am with a new set video. Now many of you are writing your TOEFL exam today. That's why I have decided to publish the video at 2 p.m. today, so that you can watch it just after reaching your home after the exam. My prayers are always with you. Hopefully you all will perform very well. Now as you know that we upload a set video on every Sunday, and it usually consists of 10 solved problems on different topics of physics. We generally upload the question paper few days before the day we upload the solution on YouTube, so that you can try to solve the questions and match your answers when the solutions are uploaded. One thing, whenever we upload a video, we distribute it to different relatable playlists. So go through the playlist and you will be able to get videos as per your choice, and keep a track of our community posts also. It will help you to make your base strong. Now only 6 days are left for your CSIR NET exam, so it is quite obvious that your preparation is at peak. You all are solving questions, reading different topics. One thing I would like to tell you here, that keep a quality time for revision. Read, practice, revise, and try to give at least 2 more full-length tests in these 6 days. And hopefully you have prepared your short notes. Now revise the short notes again and again until you can finish the whole short notes in 3 hours or less. Anyways, I will try to provide you some short notes on this channel very soon. So be in touch. Now without any further delay, let's start today's set video. So this set is set 21, and this set contains questions from electromagnetic theory. The first question reads, which of the following transformation VA, this V is scalar potential, A is the vector potential, to V prime A prime, new set of potentials of the electrostatic potential V and the vector potential A is a gauge transformation. Now gauge transformation produces same E and B. Okay, you choose some set of potential and scalar potential and vector potential, but they will also produce the same electric field and magnetic field. Now as you know, E equals to minus del V minus del A del T, and B equals to curl of A. Under transformation, this transformation, E prime will be equals to minus del B prime minus del A prime by del T. Now we have to select which of these transformation follow these things. Now we'll check the options one by one. We don't have other way. We have to check all the options to get the answer. So let's first check the first option. So option 1, V prime equals to B plus AX and A prime equals to A plus AT into K cap. Therefore E prime, okay, if we get E prime equals to E, then we will say that this transformation is a gauge transformation. So what we did, we just replaced B prime and A prime in this expression and check whether it is producing E or not. So upon producing these two values, B prime and A prime, in this expression we see that it is not equals to this A, so it is not matching, so it cannot be an option. Let's try second option. So in the same way we applied the second option, and we see that it is also not matching with the following criteria, and option 3 is also not matching. You can check, I have shown you the calculation, you can check it, but we see that option 4 is only matching with E. So option 4 is the required gauge transformation. So among these 4 options, only option 4 is giving you the gauge transformation. So option 4 is the correct option. Question number 2, the electric and magnetic fields in the charge free region Z greater than 0 are given by E of RT equals to E naught e to the power minus k1z cos k2x minus omega t j cap, and B of RT is given by this. I'm not reading it at all. Where omega, k1, k2 are positive constants, the average energy flow in the x direction is. Now as you know, the average energy flow means the average of the Poynting vector. Okay, and average power is also equals to the average of Poynting vector. So if we are given E and B, electric field and magnetic field, then we can easily calculate the Poynting vector. So that's what we did. So S equals to 1 by mu naught E cross B. So as you can see, if we take the cross product of J and I, J cross I means minus K. So it is producing minus K, and these two terms are getting multiplied. And for this case also, B means J cross K. J cross K means I. And in the question you are asked to find out the energy flow in the x direction. So we have to take the x component of the average Poynting vector. So Poynting vector in x direction, first we calculate the Poynting vector in x direction. So x direction means the I cap component. So what is the I cap component? This part into this thing. Okay, now average energy flow in the x direction means average of Sx. Now you know that average of cos square theta equals to half. So we put average of this term equals to half. So and it is producing E naught square k2 by this into this, and it is matching with option 1. So option 1 is the correct option. Question number 3. A uniform magnetic field in the positive z direction passes through a circular wire loop of radius 1 cm and resistance 1 ohm lying in the xy plane. The field strength is reduced from 10 Tesla to 9 Tesla in 1 second. The charge transferred across any point in the wire is approximately. So this is the loop, circular loop, and charge is flowing through this perimeter, and it has radius 1 cm. Now as you know that if we place some electrical wire or electrical loop in a magnetic field, then it produces current. Now we know that this induced EMF E equals to minus d phi dt. D phi dt is the change in magnetic flux, rate of change of magnetic flux. Now current, to get to know the charge, we should know the current. Current I equals to dq dt equals to E by R. This is standard Ohm's law. V equals to IR. And we know the value of the induced EMF E equals to minus d phi dt. So we just replaced the value of EMF minus d phi dt. And we know that phi equals to B dot A. B dot A is the area element, or sometimes if area is fixed and B is varying, then A dot B dB. Okay, but we can write it B dot A means B A cos 90. Sorry, it should be 0 degree. It's a wrong thing. It should be 0, because look, the direction of B is in this direction, and the area means this area, and the area of this circular loop is in the same direction, because it takes the direction of some area is taken perpendicular. So basically they are in the same direction, so the angle between them is 0 degree. So it will be 0 degree. Sorry, I have made mistake here. So BA cos 0 means 1. So this, now they told you that the rate of the field strength has been reduced from 10 Tesla to 9 Tesla in 1 second. So dB dt equals to 1 by 1. Change in magnetic field is 1 and change in time is 1 second, so it's equal to 1. So 10 minus 9 by 1, and dq we have to calculate the charge transfer across any point. So dq, and the dt is 1 because we are taking it in 1 second, so into 1. And upon replacing this value, we get 3.14 and 10 to the power minus 4 coulomb, and it is matching with option 1. Now moving to question number 4. Consider a rectangular waveguide with transverse dimensions 2 meter by 1 meter, driven with an angular frequency omega equals to 10 to the power 9 rad per second. which transverse electric TE modes will propagate in this waveguide. Now for the propagation of wave in waveguide, the angular frequency omega of the wave must be greater than the cutoff frequency given by omega mn equals to c pi root over m by a whole square plus n by b whole square, where m and n can take values 0, 1, 2, etc., etc., depending upon the modes. C is the velocity of light, and A, B are the dimensions of rectangular waveguide. Now here it is given that we have to pass angular frequency omega equals to 10 to the power 9 rad per second. So it must be greater than this cutoff frequency, and for these modes, if we discover that the frequency of these modes is cutoff frequency for corresponding to these modes is less than this, then the wave can propagate, then those particular modes can propagate through this waveguide. Okay, now the mode to propagate through this waveguide, whatever I told, it is written here. I made a spelling mistake here. Okay, unless I'm being day by day. So omega is greater than omega mn, so omega mn is less than omega. It's basically the same thing. Now we'll just test one by one, taking one mode at a time. So first we are taking 1 0. So 1 0 means m equals to 1, n equals to 0. So if you put m equals to 1, n equals to 0 means 1 by a, c pi by a. So c pi by a, we just put the value, everything is given, and we see that 4.71 into 10 to the power 8 rad per second, and the omega is given to be 10 to the power 9. So it's basically less than omega. And similarly, omega 01 is calculated 9.42 10 to the power 8 rad per second, and it is also less than omega. Omega 11 is also calculated, and we see it is greater than omega. Omega 20 is also less than omega. Omega 22 is greater than omega. Now those are the modes can propagate which are less than this omega. Okay, means this omega is greater than those modes. So as you can see, omega is greater than the corresponding transverse mode in this case, and in this case. Okay, so these three cases means W10, omega 10, omega 01, and omega 20. So only these three modes will propagate, and as you see, it is matching with one of the options, and it is option 1. Option 1 is the correct option. Now coming to question number 5, a charged particle moves in a helical path under the influence of a constant magnetic field. The initial velocity is such that the component along the magnetic field is twice the component in the plane normal to the magnetic field. So as you can see, the helical path and of diameter 2r means radius r, and the pitch is given by L. Pitch is what? Pitch is in one rotation how much linear distance it is covering, that is pitch. So if a charged particle enters in a magnetic field making some angle theta with the direction of magnetic field, then the motion is helical. And as you can see, if this is the velocity, then it will have two components, parallel components parallel to the magnetic field, b cos theta, and perpendicular component perpendicular to b. So b parallel equal to b cos theta, b perpendicular equal to b sin theta. Now radius of the helix equal to r equals to m b perpendicular by bq. This is coming from equating the Lorentz force and the centrifugal force. So mb sin theta by bq. This is the radius of this helix. Now period of revolution t equals to 2 pi r by b perpendicular. So 2 pi, and we put the value of r here, mb perpendicular by bq, and b perpendicular twice pi m by bq. Now the pitch is given by period of revolution into linear velocity. So period of revolution 2 pi m by bq, and linear velocity is v cos theta. This is a linear, it is going like this, so linear velocity is v cos theta, so into v cos theta. Now the conditions we are given that the magnetic field is twice the component in the plane normal to the magnetic field. So b cos theta, b parallel means the component along the magnetic field is 2 times the component along the perpendicular to the magnetic field. So 2b sin theta equals to b cos theta, because b parallel equal to b cos theta, and 2 into b sin theta. Now L by R means pitch by radius equals to twice pi m by bq, and radius into b cos theta, this is the value of L, and R 1 by R means bq by mb sin theta. So as you can see, it is producing 2 pi into 2b sin theta by b sin theta. Now 2b sin theta by we just replace b cos theta by 2b sin theta, so b sin theta get cancelled, so it is producing 4 pi. So it is matching with option 2. Option 2 is the correct option. Number 6. A parallel beam of light of wavelength lambda is incident normally on a thin polymer film with air on both sides. If the film has a refractive index n greater than 1, then second order bright fringes can be observed in reflection when the thickness of the film is. So as you can see, this is the film and the light is incident normally, and d is the thickness and n is the refractive index of this inside this thin film, polymer film. Now as you know, for this type of case, for bright fringes, the condition for maxima is given by twice nd cos phi prime n plus half into lambda. What is phi prime? Phi prime is the angle made by the incident light with normal. Suppose this is the plane interface, this is the normal, and if your light wave is coming in this direction, then this angle is phi prime. So here, as you can see, this is coming normal, so it is in the same direction, so the angle between them is 0. So cos 0 degree, so twice nd equals to n plus half lambda. Now for second order bright fringe, n equals to 1, because for first order n equals to 0, for second order n equals to 1. So twice nd equals to 1 plus half lambda, and it is producing d equals to 3 by 4 n into lambda, and it is matching with option 3. So option 3 is the correct option. Moving on, question number 7. A solid sphere of radius r has a charge density given by rho of r equals to rho naught into 1 minus a r by r, where r is the radial coordinate and rho naught and r are positive constants. If the magnitude of the electric field at r equals to r by 2 is 1.25 times that at r equals to r, then the value of a is. Now rho of r equals to rho naught into 1 minus a by r. This is the charge density with distance is given. Now electric field at distance r from the center of solid sphere equals to E equals to 1 by 4 pi epsilon naught r square into 0 to r rho r dv. This is standard form. Okay. E dot ds equals to q by epsilon naught. They have used the Gauss law here. So we just put the value of rho r, whatever it is given here, and just separate it and take simple integration, and we get an expression of electric field in terms of the radial distance. Now we just employ the conditions given in the question, that field at r equals to r by 2 is 1.25 times the electric field at r equals to r. We just put the value and we see that the value of a is equals to 1, and fortunately it is matching with option 2. Moving on to question number 8. The electrostatic lines of force due to a system of 4-point charges is sketched below. At a large distance r, the leading asymptotic behavior of the electrostatic potential is proportional to. Now, this type of electrostatic lines of force is possible only when you get a configuration like this. So, this is basically quadruple. We can get given field only from the following types of charge configuration, that is, charges on the corners must be same and alternate charges must have opposite sign. Monopole and dipole moment of this charge distribution are 0. Therefore, potential at far point will arise due to quadruple moment. Therefore, the potential must be proportional to 1 by r cube in the asymptotic limit. So it is matching with option 4. Now, for your convenience, I have given you some short notes on this topic. Look, this is monopole, and at if you calculate for this particular monopole, look, this is electric monopole, not magnetic, because magnetic monopole does not exist, you know it very well. So V of r at r equals to infinity means far away from the charge is proportional to 1 by r to the power n plus 1, where n is the order of multiple moment. Now for monopole, you see it is n equals to 0, so r to the power 1. So 1 by r. For dipole, P is proportional to 1 by r square. As you have seen, for dipole, potential is proportional to 1 by r square. This is the case of quadruple, where n, if you put n equals to 2, sometimes people also write L here in place of n. L is the order of multiple moment. And for octupole, this type of configuration you may get. So in some question they have given you this type of configuration. So in your upcoming net exam they may give you this type of configuration. So you can easily predict without detailed calculation that 1 by r to the power 4 means if you put n equals to 3 here, you will get this 1 by r to the power 4. So you can save it. Question number 9. A plane electromagnetic wave incident normally on the surface of a material is partially reflected. Measurements on the standing wave in the region in front of the interface show that the ratio of the electric field amplitude at the maxima and the minima is 5. The ratio of the reflected intensity to the incident intensity is. Look, they have asked you to calculate the intensity. Sometimes what we do, we just calculate the electric field amplitude and we just replace the value, and make sure that one option you will get that they will provide you the ratio of the electric field intensities, but the intensity is proportional to the square of the amplitude of the electric field. Remember that. So if you get 2 by 3 as the ratio of the electric field intensity, then the 4 by 9 will be the answer for this intensity, because that is the square of the electric field amplitude. The standing wave ratio is defined as SR equal to maximum amplitude of wave divided by minimum amplitude of, that is equals to E0I plus E0R by E0I minus E0R, and it is given to be 5. Ratio of the electric field amplitude at the maximum and minima is 5. So it is equal to 5. So from here you get E0R by E0I equal to 2 by 3. So you will be instantly redirect to choose option 2 by 3 after this. But they are asking about the reflected intensity to the incident intensity. So IR by II equals to E0R by E0I whole square equals 2 by 3 whole square equals 4 by n. Okay, so 4 by 9. So option 1 is the correct option. And here one thing I would like to tell you, intensity and continuity are not the same thing. Don't get confused. Question number 10, the last question of this set. A non-relativistic particle of mass m and charge e moving with a velocity v and acceleration a emits radiation of intensity I. What is the intensity of radiation emitted by a particle of mass m by 2, charge twice e, velocity v by 2 and acceleration 2a? Now the intensity of radiation emitted by a particle of mass m is given by I equals to 2/3 q square a square by c cube. This is the standard formula. You can write it down to make short note. Q is the charge, a is the acceleration. Now from the given data up to this we can write I equals to 2/3 e square a square by c cube. Now what will be the change in intensity if you put the mass m by, if I change the mass from m to m by 2, from charge e to 2e, from velocity v to v by 2 and from acceleration a to 2a. So intensity I prime will become 2/3 In place of charge we replace 2e, and in place of acceleration we replace 2a, and it is independent of velocity. So additionally they have given you the velocity to make you confused, but don't get confused. I know you are smart people, you will not get confused. So 2 square means 4 into 4, 16. Extra factor of 16 will come outside, and in place of this whole term we'll write I, because we calculated this. So it is I prime equal to 16 times of I, and it is matching with option A. So option A is the correct option, and this is the end. So I have tried my best to provide the solutions in great detail. Irrespective of this, if you have any doubts or confusion, you can comment down below. I'll try my best to clarify them, and any kind of suggestions are always welcome. So this is all for today, guys. If you find this video helpful, please give it a thumbs up, make the like button blue, and if you are a new visitor of this channel, please subscribe the channel and press the bell icon so that you never miss any update. Keep sharing, keep loving in this way, and what I say at the end, thanks for watching.